Okay, here's something back from your days before, heat capacity and calorimetry. Calorimetry is just a fancy term for using and measuring heat capacity. So we use this to measure the change in energy because it's a constant volume system. This is a bomb calorimeter. I showed you, or will show you, a demo, kind of it in action. But essentially, this is a known mass, known example. It gets reacted with oxygen and essentially ignited as a part of it, creating a little bomb, because a bomb is just a combustion within a closed container. Everything is known. It's going to increase the water's temperature, and based upon the water temperature, we can backtrack to determine what's in here. They often have what's called a calorimeter constant, so this amount of energy that this will self-absorb. You can see it's an energy per degree Celsius, not mass, because we already know the mass of it. We're not going to use this for ourselves because of the fact this is more of something I know I did in college, and these kind of setups are like in the tens of thousands of dollars. So a little bit above our pay grade. But I'd like you to understand how they work, because this is the way they do professional work involving calorimetry and measuring heat capacities. Now what we'll use, the coffee cup. A couple styrofoam cups. We're actually going to have a little bit of shorter versions as to do ours, but it'll work just the same. Some way to mix it, some kind of way to trap the heat. We're going to be using plastic lids. And of course you have a thermometer to measure all of what's occurring. Now, calculations, if you're trying to determine specific heat, you've got your heat over your mass times your change in temperature. We'll be doing this for a lab, but we'll also be utilizing this. This is more common because you usually know specific heat of something, and we want to know what the heat is as it's released. Now, this is the idea of a substance intrinsic ability, which means it does not matter how much you have of it, just the fact that this substance will absorb heat or release heat at the same result. Often you have it in joules per grams degrees Celsius or Kelvin. Those are interchangeable. And you can see different compounds or different elements have different amounts. They're not necessarily unique to each other. There are some that are the same, but they do vary based upon what they have. Molar heat capacity, same idea, but it's just per mole. So if that was per mole, you'd expect these values to be much higher, right? Okay, but get used to seeing any which ways. Just follow your units, and that'll help you understand which one you have to use. So we've got some things in examples here. 50 grams of each of these, each in 25 degrees Celsius, which will have the largest temperature increase if we apply the same amount of heat. Well, in looking at each of these, this one obviously is wrong because they are going to absorb energy at different rates. So looking at our lead, copper, silver, we see that there's going to take the least amount of energy in order to raise equal amounts. So we can see that thinking of our change in temperature, heat divided by the mass times the CP. If mass is equal, if Q is equal, the one that has the smallest C is going to have the biggest temperature change. Okay. These are good examples of types of multiple choice questions, but again, calculating it shouldn't be that hard either. So again, we'll get some good practice in doing these, but this should be something pretty familiar to you back from your old chemistry days. If not, it's a calculation to evolve, but these are the kind of ideas you want to develop, because quite often far too many students get caught up in doing the math, and then when they get a conceptual question, they either revert back to the math, which takes a lot of time, or they really struggle to think of the conceptual ideas of it. All right, so think about those as you come in. I'll talk to you later. Take care.